Good evening, everyone. I am K. Adishekar Babu, working as an assistant professor in the Department of MCA at Annamacharya University, Rajampet. Today's subject is Mathematical Foundations of Computer Science in MCA. In this lecture, we will discuss recurrence relations and learn how to solve them using the generating function method. Mainly, generating function is most important method in examination board. We will understand the concept step by step in a simple and clear manner. Let us begin the session. What is recurrence relation? A recurrence relation is a rule or formula that defines each term of a sequence using one or more of the previous terms in that sequence. In a sequence, that is, recurrent relation means first term and another previous terms, that is nth term, n minus 1 term, n minus 2, and so on. What is homogeneous recurrent relation? Homogeneous recurrent relation means the relation of formula, the equation or formula, that the rule equal to zero. Equal to zero means that is homogeneous recurrence relations. Not equal to zero means that is non-homogeneous recurrence relation. Now we will explain generating function. Generating function in recurrence relation. This is generating function method. Generating function method. Generating function method by solve recurrent relation. It is most important method in mathematical foundations of computer science. Let us assume a of x. Let us assume capital A of x is a generating function. A of x equal to summation n equal to 0 to infinity a n x power n be the generating function. Generating function is represented as capital A of x. A of x equal to summation n equal to 0 to infinity a n x power n. That is a naught plus a1x plus a2x square and so on. In generating function, always first term is a naught, second term is a1x, third term is a2x square, fourth term is a3x cube and so on. Step 2. Multiply each term in homogeneous recurrent relation by x power n. Multiply each term in homogeneous recurrent relation by x power n and take the summation from k to infinity. In homogeneous recurrent relation or non-homogeneous recurrent relation, multiply each term by x power n and take the summation from k to infinity. Here k to infinity means k means order of the given recurrent relation to infinity. Third step is replace the infinite terms sums by the following. Some terms in homogeneous recurrent relation or non-homogeneous recurrent relation may be replaced. That is summation n equal to k to infinity a n x power n equal to a of x minus a naught minus a1x minus a2x square, and second term is n equal to k to infinity a n minus 1 into x power n equal to x into a of x minus a naught minus a1x and so on. Third term is n equal to k to infinity a n minus 2 into x power n equal to x square a of x minus a naught minus a1x and so on. Finally, summation n equal to and so on. Summation n equal to k to infinity a n minus k into x power n equal to x power k into a of x, where a of x is the generating function for given any recurrence relation. In generating function method, mainly a of x is mandatory for all the equations. Let us discuss one example problem. Solve the recurrence relation a n minus 7 a n minus 1 plus 10 a n minus 2 equal to 0 for n greater than or equal to 2 and a not equal to 0, comma a1 equal to 1 by using generating function method. Let Let a of x be the generating function. A of x be the generating function of the given or any recurrence relation, that is a of x equal to summation n equal to 0 to infinity a n x power n, that is equal to a naught plus expand of given a of x is a naught plus a1x plus a2x square and so on. Given recurrence relation is an minus 7 an minus 1 plus 10 an minus 2 equal to 0. This is equation number 1. Now, second step is multiply each term of equation 1. Multiply each term of equation 1 by x power n and take the summation from n equal to k to infinity. That means here given recurrence order is 2. Starts from n equal to 2 to infinity. Now, summation multiply given recurrence relation by x power n and take the summation also from n equal to 2 to infinity. N equal to 2 to infinity a n x power n minus 7 into summation n equal to 2 to infinity a n minus 1 x power n plus 10 into summation n equal to 2 to infinity a n minus 2 into x power n equal to 0. This is equation number 2. Now we find the one by one term, one by one term. That is, first term is summation n equal to 2 to infinity a n x power n equal to expand the given term is substitute n equal to 2 a2 x square plus next substitute n equal to 3 a3 x cube plus a4 x power 4 and so on. What is the first term of generating function sequence? First term is a naught. Na a naught plus a1 a naught. Here a naught and a1x is missing, so add the a naught and a1x and subtract the a naught and a1x. A naught plus a1x plus a2x square and so on minus a naught minus a1x. Here a naught plus a1x plus a2x square, this is equal to a of x. A of x minus a naught minus a1x, this is equal to a2x square plus a3x cube plus a4x power 4. Here generating function is occurred. Next step is summation n equal to 2 to infinity a n minus 1 into x power n equal to substitute n equal to 2 in given a n minus 1 into x power n. a1x square plus a2x cube plus a3x power 4 and so on. Here also a1 term coefficient x square coefficient is always a2, but here a1 is there. Now x common x in the given recurrence, x into a1x plus a2x square plus a3x cube and so on. Here also a naught is missing. A naught is missing now. A naught, by adding a naught and subtract a naught, by we get the a of x. X into a naught plus a1x plus a2x squared plus a3x cube and so on minus a naught, that is equal to x into a naught plus a1x plus a2x squared plus a3x cube is equal to a of x minus a naught. X into a of x minus a naught, that is equal to x a of x minus x a naught. Finally, last term is summation n equal to 2 to infinity a n minus 2 into x power n, that is equal to a naught x square plus a1 x cube plus a2 x power 4 and so on, that is equal to, here a naught term is always single term without coefficient. Here coefficient is there, so x square common x square into a naught plus a1x plus a2x square and so on, that is equal to a naught plus a1 plus a1x plus a2x square is equal to a of x square into a of x. Substitute these values in equation 2. We get a of x minus a naught minus a1x minus 7 into x a of x minus x a naught plus finally 10 into summation n equal to 2 to infinity a n minus 2 x power n is equal to x square a of x. X square a of x equal to 0. A of x minus a naught minus a1x, here 7 into 7 into x a of x plus 7x a naught plus 10x square a of x equal to 0. Here, common a of x in both terms. A of x into 1 minus 7x plus 10x square minus a naught minus 7x plus 7x a naught equal to 0. A of x into 1 minus 7x plus 10x square equal to a naught plus 7x minus 7x a naught. Here in the question, a naught equal to 0, a1 equal to 1. Substitute a naught and a1 values. A of x into 1 minus 7x plus 10x square equal to 0 plus x minus 0, that is equal to only x. A of x equal to x by, here a of x multiply, then it will change the LHS to RHS. Here multiply, then divide. So x by 1 minus 7x plus 10x square. Here find the roots of a given quadratic equation. Find the quadratic equation is 1 minus 7x plus 10x square equal to 0. That is 1 minus 5x minus 2x plus 10x square equal to 0. That the roots are 1 minus 5x and 1 minus 2x. A of x equal to x by 1 minus 5x and 1 minus 2x. By using partial fractions. In generating function, by using partial fractions, we solve the main solution. By using partial fractions, a of x equal to capital A by 1 minus 5x plus capital B by 1 minus 2x. Here, a of x equal to x by 1 minus 5x into 1 minus 2x equal to, here cross multiplication is applied, a into 1 minus 2x plus b into 1 minus 5x by 1 minus 5x into 1 minus 2x. Here 1 minus 5x into 1 minus 2x, here also 1 minus 5x into 1 minus 2x. 1 minus 5x, 1 minus 2x cancel. Finally, x equal to a into 1 minus 2x plus b into 1 minus 5x. Now, we find the a and b values. A and b values by solving case 1 x equal to 1 by 2 and case 2 x equal to 1 by 5. Substitute x equal to 1 by 2 and x equal to 1 by 5, we get a and b values. Here x equal to a into 1 minus 2x. Substitute x equal to, here 1 minus 2x now. Now that's why substitute x equal to 1 by 5. X equal to 1 by 5 equal to a into 1 minus 2 into 1 by 5. 1 by 5 equal to a into 3 by 5. Finally, a equal to 1 by 3. X equal to b into 1 minus 5x. B equal to 1 minus 5x. Substitute x equal to 1 by 2. 1 by 2 equal to b into 1 minus 5 into 1 by 2. 1 minus 5 into 1 by 2 value is minus 3 by 2. 1 by 2 equal to b into minus 3 by 2. b equal to b equal to 1 by 2 into minus 2 by 3. Here 1 by 2 2 cancel. Finally, b equal to minus 1 by 3. A equal to 1 by 3 and b equal to minus 1 by 3. Substitute a and b values in partial fractions equation. Now a of x equal to 1 by 3 into 1 minus 5x plus minus 1 by 3 into 1 minus 2x. That is 1 by 3 into 1 minus 5x minus 1 by 3 into 1 minus 2x. 1 by 3 into, here 1 minus 5x is multiply here, then in denominator 1 minus 5x. To change the numerator, 1 by 3 into 1 minus 5x whole power minus 1 minus 1 by 3 into 1 minus 2x whole power minus 1. This is the reciprocal term. Reciprocal term. Reciprocal term. 1 minute. No? Here one more is missing. This is 1 by 3 into 1 minus 5x whole power minus 1 minus 1 by 3 into 1 minus 2x whole power minus 1. A of x equal to 1 by 3 into here 1 minus 5x whole power minus 1 formula is summation n equal to 0 to infinity 5 power n x power n minus 1 by 3 into summation n equal to 0 to infinity 2 power n x power n. That is equal to A of x is equal to n equal to 0 to infinity a n x power n and summation n equal to 0 to infinity 1 by 3 into 5 power n minus 1 by 3 into 2 power n. Here x power n is common. X power n is common in both terms. So divide the x power n. Comparing by equating the x power n coefficients. X power n coefficients ni by compare x power n coefficients. Here x power n, here x power n is cancelled. N equal to 1 by 3 into 5 power n minus 1 by 3 into 2 power n. This is the main solution of the given recurrence relation in generating function. This is a general solution. Therefore, an equal to 1 by 3 into 5 power n minus 1 by 3 into 2 power n. Thank you.